Okay, we are solving radical equations today. Throw your name on here. These have no back, so you'll be able to just glue them in. And this is second hour currently. Okay, so before we worked on that booklet, we talked about square roots. So we've got this little square root. I want to, just for everyone's eyeballs again, and so it's in the video, remind you where that square root button is in your calculator. If I need to find, let's say, the square root of 100, that's me saying what number times itself equals 100, which is 10. In my calculator, I'm going to use the second key over on the left here, and then the x squared key, the square root is right above it. So I hit that, it's like a shift key. So square root of 100 is 10. Okay, so a square root is us asking ourselves what number times itself equals this number. Up until now, we have had two sets of opposite operations. Addition is the opposite of subtraction. Multiplication is the opposite of division. We now have another set that we're bringing to the table. Square roots are the opposite of squaring something. So, we're still trying to solve for x. We're still trying to get that variable by itself. But at some point, we're going to have to get rid of a square root. When we have to get rid of that square root, we're going to do it by squaring both sides of our equation. So, our steps to solving a radical equation. Step 1 is to isolate the square root. What does it mean to isolate something? Get it by itself, put it on its own. So we're going to get the square root by itself. Get rid of everything that's outside of the square root first. Then we can get rid of that square root. And we do that by squaring both sides of our equation. And then our last step is going to be to isolate the square root. Isolate the variable. We've already isolated the square root. Once you get rid of the square root, you just keep solving for x. And that would be us isolating the variable. So just like with all other equations, when we work backwards, we need to work backwards, and then in the middle, or sometimes it's at the beginning, sometimes it's at the end, we'll get rid of the square root by squaring both sides. So we've got 3 examples. One where it's in the middle, one where it's at the beginning, one where it's at the end. So you guys can see that. Everyone got those blanks? Okay. Moving down here. We've got square root of 12x all over 2 equals 3. I'm going to ignore the equals 3 for right now. What is outside of my square root on the left side?
2.
The divided by 2. So that is outside of my square root. See how that is not inside the little house that's my square root? That means I need to get rid of that first. So I'm going to multiply both sides by 2. These cancel. So now I've got square root of 12x equals 3 times 2 is 6. Okay. Now, what is outside of my square root? Nothing. So I've got that equals 6 there. We can ignore that. On the left side of my equation, there is nothing outside of my square root. So that means I'm ready to get rid of my square root. So I can square both sides of my equation. So square here, square here. This square root and square cancel each other out. So all I have left on the left is 12x. And then on the right side, what is 6 squared? 36, not 12, 36. Multiply it by itself. Don't multiply it by 2. And then once you get rid of your square root, it's just a normal equation. So from here, I can divide both sides by 12. I get x equals 36 divided by 12 is 3. So I put in pink that new step, squaring both sides. All right, any questions right now? All right, let's move on to that next one then. What is outside of that square root? Nothing. So see how it's tall and that divided by 2 is inside of it? That means we can't touch that divided by 2 yet. We can't touch anything inside the square root until we get rid of the square root. So in this problem, there is nothing we need to do to isolate the square root. We are ready to just square both sides. So I'm going to square both sides. On the left side, that square root and the square cancel. So I just have 5x over 2 still equals, and then 5 squared is 25. And then from here, it's a normal equation. I'm going to multiply by 2 on both sides. These 2's cancel, so I've got 5x equals 25 times 2 is 50. And then I divide by 5. I get x equals 10. Hey, any questions right now? So this one, we were able to get rid of the square root right away. The very last one here. What is inside the square root on this problem? Just, okay, so look at where the square root is. The x is under it. What else is underneath the square root? Nothing. So we've got to get rid of that minus 5 and that 3. If this were an equation that just said 3x minus 5, what would we do first? Plus the 5. So we can get rid of that plus 5 first. So we're going to add the 5 to the other side. We'll have 3 times the square root of x still equals 13 plus 5, which is 18. And we can divide both sides by 3. Because that's also outside of my square root. And I have square root of x equals 18 divided by 3 is 6. I cannot touch that x until I get rid of the square root, and there's nothing else in the square root with the x. Okay. Now, how do I get rid of the square root? Squaring. Square roots and squaring are opposites. Square both sides, square root of and squared cancel each other out, so I just have x, and then 6 squared is 36. Okay, so I tried to make it clear it's in the pink where we square each time. So sometimes we do some work and then square it in the middle. Sometimes we square at the very beginning. Sometimes we square at the very end. You cannot square both sides of your equation until you isolate your square root though. Okay, I'm going to go ahead and stop this video while you guys glue in your notes.